Hi, I'm Sean Gannon, and this is Minute Math. And we got a fun geometry problem here. We were given this figure, and we want to find the radius of the circle. And what do we know here? Well, we have a circle here, and we have some, well, right angles and line segments within it. Here we have line segment 4 going on, right angle to line segment that's 6 units long, to a right angle which goes to 2 units long that touches the circle again. With only this information, can we find the radius of the circle? So I want you to pause this video and see if you can figure out this problem here, okay? If you struggle or you just want to watch, well, we're gonna dive on in right now. Okay, first thing I like to do when I solve these problems is I like to label some points. So we have a reference that we're talking about here. Let's start with this point, let's call it A, this one B, and we'll call that one C right here on the perimeter of the circle, and let's call this one here D, right there. All right. Now with this, I'm gonna actually extend some lines, what we know, all right? So I have the line segment BD. I'm gonna make that into a full-on chord. I'm gonna extend it all the way to the end of the circle, right here. And we have a little point here, and I'm gonna call that, what did I call it? I called it E. I'm gonna do the same thing with line segment CD. I'm gonna extend this down here, keep going, hopefully it stays vertical, right? Extend it all the way down till it hits the circle again, right here at this point here, and I call that point F, all right? So now we have two chords going on here from, well, CF and then BE now. I'm also gonna make a horizontal line from A over to line segment CF here, okay? So we have a horizontal line. I'm gonna make a right angle, so make sure it's horizontal here. Right angle, go across here, so I'm creating, don't mess up there, Sean. A right angle here, all the way across to this point here. So I'm drawing it, so this is a right angle, and this is a right angle. And let's go label that point, what did I call it? P, I think I call it point P here, point P. All right, so we have A, B, C, D, E, F, P. All right, well, what do we know here now about this intersection? We have right angle here, because this is gonna be perpendicular. Then we actually, well, we know this is a right angle here. We know this is a rectangle, A, B, D, P. A, B, D, P is a rectangle. Okay, it's a rectangle. So what do we know about their opposite side lengths? They're going to be congruent. So AP has a length of 6 and DP has a length of 4. We got some nice information here for our circle. So now we're going to apply our symmetry property. Let's think about this. We have a rectangle ABDP. The side length there AB is touching both endpoints on the circle here, right on. For that to be a rectangle and touching these 2 points, it has to be symmetric above and below that center line right there. Okay, so we can have a rectangle. So what does that tell us? Well, that tells us here that CD is equal then to PF, that length there. So that's also gonna be a 2 here. So now we can find some more lengths within, well, this circle. We have BE, length BE is equal to 6 plus 2, which is an 8. And then CF is 2 plus 4 plus 2, which is also equal to 8. And that's a CF. But what is the length of DE? We don't know what that is. DE. So DE, we want to find that length, and we're actually going to use the intersecting chords theorem. And if you remember this theorem, we have this circle here, we have 2 chords, A, B, C, D, are our line segment lengths. And it tells us that A times B is equal to C times a D here, all right? So we're gonna apply that with our circle. 6, let's call that A, so we have 6 is an A here, B to D, and then we don't know what DE is, times a DE, whatever that length is equal to a 2, the length of CD, times 4 plus 2, which is 6, or 4 plus 2, which is 6, right there. Simplify that, divide 6 to both sides, this is easy, and DE also has a length of 2, right there. So DE also has a length of 2. So now watch this. We're gonna take AP, let's extend this slightly here, going on, and symmetry would tell us here, let's call it point Q. And symmetry would tell us that, well, this is a big rectangle right here, okay? Now, bear with my points here. Got a big rectangle. Not drawn to scale, so bear with me here. We got some right angles going on there. Now, if I connect the points, or the lines, point segments, points, not point segments, points AE here, watch this. AE across the middle, right here, that tells us that the exact middle of that segment here is going to be the center because we have a rectangle that is inscribed in a circle, right? A rectangle that's inscribed in a circle, that hypotenuse will intersect the center of the circle. So we gotta go figure out what that hypotenuse length is, and we'll get the diameter, and then we can cut that in half. So good old Pythagoras tells us a squared plus b squared equals c squared equals b squared equals c squared. Let's call a 4 plus b squared is 6 plus 2, which is an 8 squared, which is ac squared right here, okay? 4 squared 16 plus a 64, 8 squared equals c squared. 16 plus 64, that gives us an 80 equals c squared. Square root both sides, and c equals, I simplified this out here, is the square root of 80, which is equal to a 4 square root of 5. But remember, that's just the diameter. That's our length of AE. Our diameter of the circle, we need to cut that in half, and so our radius equals 4 square root of 5 over 2, which is equal to a 2 square root of 5, which is approximately, I wrote this down, 4.4721. But I like 2 square root of 5 better. So our radius of our circle here is 2 square root of 5. Did you get this problem? If you did, way to go. It's actually a pretty hard problem. If you didn't, no worries. I hope you learned the steps here, how we can solve this, and hopefully you learn from it and you can solve one in the future. So, hope you liked this video. Again, if you did, like the video, subscribe to our YouTube channel. This helps us make more of these fun math videos for you and for everyone else. So as always here, thanks for watching.